Mercury, the closest planet to the Sun, is a captivating sphere shrouded in cosmic mysteries. With a diameter of approximately 4,880 kilometers, it stands as the smallest among the planets in the solar system. Despite its proximity to the Sun, Mercury's peculiarities make it a unique world. The most distinctive features of Mercury are related to its inhospitable environment. Without a significant atmosphere to shield it, the planet faces temperature extremes that defy imagination. During the day, Mercury's surface can reach scorching temperatures of up to 430 degrees Celsius, while at night, the absence of an atmosphere to retain heat causes temperatures to plummet drastically to -180 degrees Celsius. The lack of atmosphere also contributes to another intriguing aspect of Mercury, its landscape. Devoid of a dense atmosphere to shield it from meteoroid impacts, Mercury's surface displays an abundance of impact craters, silent witnesses to billions of years of cosmic interactions. These planetary scars, carved over eras, reveal the tumultuous history of the solar system. In addition to craters, Mercury exhibits a peculiar feature known as scarps. These terrain faults, stretching for hundreds of kilometers, result from tectonic forces that have shaped the planet's surface over time. The absence of a significant atmosphere allowed these formations to remain virtually unchanged, providing scientists with a unique glimpse into the geological forces at work on Mercury. Mercury's peculiarity also extends to its orbital motion. Its rotation period is notably slow, taking about 59 Earth days to complete one rotation on its axis. Surprisingly, this period is nearly twice as long as the time it takes the planet to orbit the Sun, meaning a day on Mercury is longer than a year. Mercury's elliptical orbit and eccentricity contribute to a phenomenon known as orbital precession. This oscillatory movement in its orbit influences how the planet interacts with the Sun's gravitational field, creating unique challenges for scientists attempting to understand Mercury's intricate orbital motions. Despite the challenges posed by its proximity to the Sun and lack of atmosphere, Mercury has been the subject of intense study and exploration. The Messenger spacecraft, Mercury Surface, Space Environment, Geochemistry, and Ranging, launched in 2004, provided a more detailed view of the planet, mapping its surface and collecting valuable data on its composition and geology. The discovery of water ice in Mercury's polar craters was a surprising find from the Messenger probe. In permanently shadowed areas where temperatures are low enough, water ice was detected, challenging expectations for a planet so close to the Sun. This discovery raises intriguing questions about the origin of this ice and how it remains intact in Mercury's extreme conditions. In the not-too-distant future, exploration of Mercury will continue with the Bepicolombo mission, a collaboration between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. This ambitious mission aims to deepen our understanding of the planet by analyzing its composition, magnetosphere, and other aspects that still challenge our comprehension. In summary, Mercury, the closest planet to the Sun, continues to surprise and intrigue scientists with its desolate surface, extreme temperature variations, and complex orbital movements. As space exploration advances, new discoveries on Mercury are destined to expand our knowledge of the formation and evolution of planets in our solar system. Mercury has a unique elliptical orbit, meaning the distance between it and the Sun varies significantly during its orbital path. Its name is derived from the Roman god Mercury, the messenger of the gods, due to its rapid orbit around the Sun. Mercury has an unusual orbital eccentricity, leading to a phenomenon known as orbital precession, affecting its orbit over time. A day on Mercury, with its slow rotation, is longer than a year, as it takes about 59 Earth days to complete one rotation. The lack of a significant atmosphere means Mercury has no blue sky, colorful sunsets, or greenhouse effect. Surface temperatures on Mercury vary drastically, reaching scorching extremes during the day and freezing temperatures at night. Mercury is the densest planet in the solar system, surpassing even Earth. The planet has the smallest axial tilt, meaning it has an almost vertical orientation in relation to the orbital plane. Its rotation is synchronous at a 3:2 rate, meaning for every 2 years on Mercury, there are 3 days. The lack of atmosphere prevents small meteoroids from burning up, creating a surface filled with impact craters. The Bepicolombo mission, a collaboration between ESA and JAXA, is the most recent mission dedicated to exploring Mercury. Mercury is one of the 5 planets visible to the naked eye from Earth and was known to ancient astronomers. The absence of a dense atmosphere allows small meteoroids to impact Mercury's surface, creating a cratered landscape. The Messenger spacecraft mapped approximately 40% of Mercury's surface, revealing previously unknown details. Mercury is often called the Sun's twin due to its proximity and high surface temperatures. The escarpments on Mercury can reach impressive heights, creating dramatic geological formations. Messenger discovered that Mercury has a global magnetosphere despite its relatively small iron core. Mercury is a terrestrial planet, similar to Earth, Mars, and Venus, with a rocky surface. The combination of scarps and craters creates a unique landscape, telling the story of Mercury's geology. Mercury's orbit is so fast that, in one Earth year, it completes about 88 orbits around the Sun. The diurnal period on Mercury is longer than its orbital period, leading to a unique dynamic of days and nights. Mercury is visible to the naked eye before dawn or after sunset, depending on its orbital position. Mercury's slow rotation results in extreme daytime heat, while at night, the lack of atmosphere allows heat to escape rapidly. Messenger identified several impact basins on Mercury's surface, indicating catastrophic events in the past. The Caloris Basin, one of the largest on Mercury's surface, has a diameter of about 1,550 kilometers. Messenger revealed that particles of water ice in the polar craters can coexist with darker materials. The thin atmosphere of Mercury is composed mainly of traces of oxygen, sodium, hydrogen, and helium. Mercury experiences significant thermal expansion due to its extreme temperature variations. Messenger performed several complex gravity assist maneuvers to reach Mercury's orbit. The lack of a thick atmosphere on Mercury means there are no weather phenomena, such as wind or rain. Mercury's core is primarily composed of iron and nickel, suggesting a formation similar to Earth's. Messenger found evidence of ancient volcanism on Mercury, indicating a more complex geological history than previously thought. The rarefied atmosphere of Mercury is unable to scatter light, resulting in a consistently black sky during the day. Messenger discovered that Mercury's scarps were formed by the planet's contraction due to core cooling. The topography of Mercury includes vast plains, mountains, and geological faults. The challenge of sending probes to Mercury lies in overcoming the strong solar gravity. The Messenger probe made detailed observations of Mercury's atmosphere during its Earth flyby before reaching the planet's orbit. Mercury was visited by only 2 space missions so far, Mariner 10 and Messenger. The impact that formed the Caloris Basin may have been so powerful that it affected the opposite side of the planet. Mercury is often brightest when seen from Earth just before dawn or after sunset. Due to its eccentric orbit, the sunset on Mercury appears to slow down, then retrograde before continuing its movement. The Messenger mission revealed that some Mercury craters harbor deposits of volatile materials, such as sulfur. Mercury does not have moons, making it one of the few planets in the solar system without natural satellites. Messenger found that ice particles in Mercury's polar craters can coexist with darker materials. Mercury's magnetosphere is 100 times less intense than Earth's, providing little protection against solar wind. Messenger discovered evidence of ancient volcanism on Mercury, suggesting a more dynamic geological history. Because of its eccentric orbit, Mercury's sunset appears to slow down and then reverse before continuing. Messenger made detailed observations of Mercury's atmosphere during its Earth flyby before reaching the planet's orbit. Due to its high eccentricity, Mercury's orbit contributes to the extreme temperature variation between its daytime and nighttime sides. Messenger made use of several gravity assist maneuvers to adjust its trajectory and reach Mercury's orbit. Mercury has a relatively weak magnetic field compared to Earth, and it is believed to be generated by a partially molten iron-nickel core. The Caloris Basin on Mercury's surface, created by a massive impact, has a ring of mountains along its rim, forming a geological bullseye. Mercury's atmosphere is so thin that molecules can escape into space at an accelerated rate, creating a constantly escaping exosphere. The Messenger spacecraft discovered hollows on Mercury's surface, small depressions possibly formed by the sublimation of volatile materials. The impact that formed the Caloris Basin may have generated shockwaves that traveled through the planet and created the unusual, weird terrain on the opposite side. Mercury's lack of a significant atmosphere means there is no sound, as sound requires a medium through which it can travel, like air. Mercury's rotation is unique in that it experiences both prograde and retrograde rotation due to its 3:2 spin-orbit resonance. Mercury's eccentric orbit causes a phenomenon called perihelion precession, where its closest approach to the Sun shifts gradually over time. Despite its scorching temperatures, there are regions on Mercury where ice can exist in permanently shadowed craters, shielded from the Sun's heat. Mercury's surface reflects sunlight almost as well as fresh snow on Earth, making it one of the most reflective planets in our solar system. The Messenger mission observed unusual dark streaks on Mercury's surface, possibly formed by the movement of material within the planet's crust. Mercury's lack of an atmosphere means it has no protective shield against solar radiation, exposing its surface to intense sunlight and solar winds. Mercury's orbit is inclined relative to the ecliptic plane, leading to unique observational challenges for telescopes on Earth. The lack of substantial volcanic activity on Mercury's surface suggests that its internal heat may be decreasing over time. Mercury's day-to-night temperature difference is so extreme that certain materials, like lead, would melt during the day and solidify at night. The Messenger spacecraft made multiple flybys of Mercury before entering orbit, using the gravitational assists to adjust its trajectory efficiently. The Messenger mission detected sodium in Mercury's exosphere, likely originating from the planet's surface. Mercury's axial tilt is close to zero, meaning it has little to no seasonal variation in terms of temperature and sunlight distribution. The Messenger spacecraft found evidence of volcanic vents on Mercury, providing insights into the planet's geological activity. Mercury's rotation is so slow that, relative to the Sun, a day on the planet is longer than a year.